Welcome to educator.com. This lesson is about proportions. In this lesson, we're going to identify and solve proportions. Some applications are to find exchange rates and also to increase recipes for larger groups. A proportion is an equation stating that two ratios are equal. So for example, 2 over 3 is equal to 4 over 6. You may have also seen this in equivalent fractions. Two ratios that are equal are also equivalent fractions. And in algebra, this would be A over B equals C over D, where B does not equal 0 and D does not equal 0. Remember that denominators are undefined as 0. Cross products. Cross products are always equal for proportions. So for example, if you have 2 over 5, which equals 4 over 10, the cross products would be 2 times 10 and 5 times 4. Notice that they would both equal 20. That is one way to find out if your proportions are equal. And in A over B equals C over D, you would be multiplying AD and BC. And these would also be equal, remembering that B and D will not equal 0. Do the ratios form a proportion? Explain. So let's try finding out if these two proportions are equal. 9 over 11, does that equal 63 over 77? Well, if I want to look at them as equivalent fractions, I notice that 9 times 7 will give me 63, and if I do the equivalent times 7 on the bottom, I will get 77. So if I wanted to explain, I could say, yes, these proportions are equal because I can multiply the numerator and denominator, or the top and the bottom of the ratio, by 7 and come up with the equivalent proportion of 63 over 77. Let's try this next example. 16 over 27, does that equal 4 over 9? If I do 16 divided by 4, that will give me 4. However, 27 divided by 4 is not 9. So these proportions are not equal. And as an explanation, I could say 16 over 27 does not equal 4 over 9 because I cannot divide both the top and bottom by the same number to get 4 over 9. Let's try solving proportions using two methods. One method is by creating equivalent fractions, as I just showed you on the last slide, multiplying by the same number or dividing by the same number. And the other method we reviewed in vocabulary, where we used cross products. Let's try x over 4 equals 12 over 21. Is there any easy number to multiply with 4 to get to 21? A whole number? No, there isn't. So I'm going to use the method of cross products. X times 21, or 21x, is the same as 4 times 12, 48. And to simplify that, I'm going to divide by 21. So x will equal 48 and 21. It will go in twice, giving me 42 with a remainder of 6. So x equals 21 and 2/6, or 21 and 1/3. Let's check that. So the cross product is x times 21, 21x, and 4 times 12 is 48. And then to solve for x, we divide both sides by 21. Oh, this is 2. Sorry about that. I knew it looked a little bit too big there. It would be 2 and 1/3. Which makes sense because if we come back to our original portion, 12 is a little more than half of 21, and 2 and 1/3 is a little more than half of 4. So that makes more sense there. Now let's try 20 over y equals 15 over 9. There is no whole number that I can multiply with 20 to get to 15, so I'm going to use cross products. 20 times 9 2 times 9 is 18. So 180 equals 15y. Going to divide both sides by 15. 180 divided by 15 goes in once. Into 30 will go in twice. So y equals 12. Now let's remember to come back and check if our answer makes sense, because I caught it on the last problem. 20 is larger than 12, almost double 12, and 15 is larger than 9, almost double 9. So yes, 12 will make sense. In this case, we could not use creating equivalent fractions because there was no clear whole number to multiply or divide by. We had to use cross products. And cross products is a very good method to know because it always works for solving proportions. If the proportions are, it always works for solving proportions. Let's try solving proportions in word problems. You exchanged 260 euros for $320.15. Let's put in our dollar sign here. Find the unit rate of exchange. So if you have 260 euros for every $320.15, we're looking for the unit rate. Remember, the unit rate means for one. So they're talking about for $1 here. And we're looking for the rate of exchange. So let's say for euros. So I'm going to cross multiply. 260 equals 320.15 E. Now to solve for E, I'm going to divide both sides by 320. That cancels to 1. I've isolated E, and now I need to do some dividing here. 320.15. I have 2 decimal places, so I'm going to move it twice, so that means I'm going to have 2 more here. So I have 32,015. And that's not going to go in here. So I have 5 places, 5 here, so I'm going to put a 0 and a 0 here. And a decimal. And now we need to estimate that. Well, to estimate, it's helpful to look at the first 2 numbers. And 3 goes into 26 about, let's say, 12 times. So let's try this by 12. Well, 12 is not going to work here, so let's try it by 9. 45, 4, 9, 13, 18, 27, 28. So that's too big, so let's try by 8. 40, 8, 12, 16, 24, 25. That looks very close. So I'm going to say by 8, 2, 5, 6, 1, 2, 0. 0, 10 minus 2 is 8. 9 minus 1 is 8. 9 minus 6 is 3, and I borrowed. And that's going to go in, if I put another 0 here, it's going to go in 1 time. So I'm going to have 3, 2, 0, 1, 5. 10 minus 5 is 5. I borrowed. So that one's going to be a 9, and 9 minus 1 is 8. And I borrowed, so that's going to be a 7 minus 0. And I haven't borrowed anymore, so 6. And if I continue it another 0, it's going to be about 2. So at that point, we could stop, and we could say for the euros per dollar is 0.812. So for every $1, the exchange rate is 0.812 euros. So not even quite €1, which if we come back to our original ratio makes sense because $320.15 is more than the amount of euros that you get. So you don't get 1 full euro for every $1. And this would be a great problem to check with your calculator and check how many decimal places it goes, or to check the problem if the problem tells you how many decimal places it requires you to multiply the number to. Does this ratio form a proportion? Explain. 72 over 27 equals 8 over 3. Well, to go from 72 to 8, I would divide by 9. So then let's try dividing by 9 on the bottom and see if we get the same. 72 divided by 9 is 8, yes. 27 divided by 9 is 3, yes. So does this ratio form a proportion? Yes. And you could explain this by saying, I can create an equivalent ratio by dividing the given ratio by 9. So a proportion is simply two equivalent ratios. 12 over 9 equals x over 12. So there is no clear way to go from 9 to 12 with a whole number, dividing or multiplying, so I'm going to use cross products. 12 times 12 is 144, and 9 times x is 9x. And now to solve for x, I'm going to divide both sides by 9. 144 divided by 9, it'll go in one time, leaving me with 54, and it'll go in 6 times. So x equals 16. And let's come back to our original problem. 12 is greater than 9, and 16 is greater than 12. So our answer does seem reasonable. You enlarge a photo that is 5 inches wide and 7 inches long. The sides of the new photo are in proportion to the original. The new photo is 12 inches wide. Find the length of the new photo. So I have 5 inches wide, and that relates to 7 inches long. That's the original photo. And the 5 inches, which is in proportion, relates to the 12 inches wide. And so what we're finding out is the new length. So I'm going to call that L for length. I'm going to solve this by cross multiplying. 5L equals 7 times 12, which is 84. And now to solve for L, I'm going to divide both sides by 5. 84 divided by 5, 1. 34 goes in 6 times, which is 30. And it'll go into 40 8 times. So the new length of your photo is going to be 16.8 inches, which makes sense because 7 is a bit longer than 5 and 16.8 is a bit longer than 12 inches. So if you have a photo that you want blown up and you want to keep it in proportion so that the picture does not become distorted, you would want to create a picture that is proportionate. A car can travel 108 miles on 6 gallons of gas. Find out how far the car can travel on 10 gallons of gas. So if you're taking a trip and you're able to fill up your car to 10 gallons of gas, and you want to find out if this is going to get you as far as you need to go. So we know that 108 miles works for 6 gallons. So let's find out for 10 gallons. Remember, when you set up a proportion, your units need to be lined up to each other. So gallons and gallons on the bottom and miles on the top. If you want to flip it around and write gallons and gallons on the top and miles on the bottom, that's fine. Just make sure that you keep your units lined up. And we're looking for, let's say, m miles. So to create cross products, I'm going to have 108 times 10. Remember, when multiplying by 10, you can always just tack an extra 0 onto the end. And this is going to be 6m. To solve for m, I'm going to do the inverse of multiplying by 6 and divide by 6 to both sides. And I get m. And over here I have 1080 divided by 6. It will go in one time. 48. It will go in 8 times. And remember that you still need to bring down this 0. So instead of 18, you in fact have 180. So 180 miles. So the car can travel 180 miles. Let's see if that makes sense. Yes, because at 6 gallons it goes 108, so at 10 gallons it should go quite a bit farther to 180 miles. Thank you for watching Educator.com.